Hello there and welcome back. My name is Michael Fudge. This is Lesson 7 in our Learn to Program in Java series. Lesson 7 picks up where Lesson 6 left off, that is, in class design. We'll be doing more class examples today, but we'll also be introducing two new wrinkles. That is, how can you define and document your classes through JavaDocs, and how do you know that the code you're writing, the methods that you write in your classes, actually work? Unit testing, in other words. So a quick tour for today's agenda. We'll do more classes and object-oriented programming type concepts. We'll show you how you can organize your projects into packages and then reuse those packages. And along the way, we'll introduce some JavaDocs and unit testing. Getting right into it here, today's example will be playing cards. So if you're familiar, there's 52 cards in a deck, and the deck has suits like spades, diamonds, clubs, and hearts, and ranks like 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. And for any given card, we want to look at different behaviors, like is the card red or black? Is it the same suit? Is it the same card as another card? And we'll also implement an overridable method of toString so that we can print our cards. All right, let's dive right into it. I think everybody understands the concept of a playing card, but you might be just remotely curious as to how we're going to implement this in Java. There's a couple ways that you could do this, but I chose to do it the way I did because of everything that you've learned so far in the class. If this was lesson 14, I might have approached this problem a little differently. That's my caveat. Okay. Let's get started. Here I am out in the NetBeans IDE, and I've already created a new project called Playing Cards Example. And in there I have one package named Playing Cards Run, and then a Java file called Playing Cards Run Java. And the reason I did this is because I'm going to build my own package that's just going to contain the classes associated with playing cards, and I'm going to put that in a package called playing cards. And I want that package to be different from this package here because I need that jar to be reusable in other projects, as you'll see in the future. Okay, so let's start by making a new package. I'm going to right click on source packages and select new package. This package is going to be called playing cards. Now inside this package I'm going to need some class libraries. Now when you think of a playing card, it consists of suits and ranks. So I'll make a class for each of these. I'll make a class for suits and I'll make a class for ranks. If you're unfamiliar with playing cards, you might be saying, well, what is a suit or a rank? In the picture that you see here, the rank of the first card to the left is a 10, and the suit is spade. So the 10 and the ace share the same suit, a spade. The rank is pretty much the point value of the card. So it goes, 2 through 10, and then the next highest value is jack, then queen, then king, then ace. So I will first implement this in a class, and then I will implement the card class from the suits and ranks class. This is called building a class through composition. So let's do that now. So I'm going to create a new class. This class is going to be called ranks. I've got my empty class here. Now it's time to fill it up. Public static final int 2. Public static final int 3. And so on and so forth. Okay, through the magic of editing, I have added all 12 ranks that appear on a playing card, 2 through ace. Now some of you might be saying, well, why didn't I use the value 2 for 2, and why didn't I use the value 3 for 3? Why did I use 0 for 2 and 1 for 3? And this will become evident in a little bit when you realize how I'm implementing the playing card. Like I said, there's many ways that you can do this. I'm doing it in a certain way so that I can leverage the power of mathematics to create my playing cards quite easily. Some of you will be impressed. Some of you will call me a nerd. I don't know. So these are my ranks. You might be saying, what is public static final int? Whew, that's a mouthful. Well, int is the data type. Public means it's accessible outside the ranks class. Static means you can use 2 and 3 and 4 without declaring a variable of type ranks. So I don't have to say ranks are equals new ranks, and then I could use 2 or 3 or 4. I can use them right away because they're static. And final means it's a constant. The value does not change. So what I'm saying here is declare a public constant that I do not need to declare as part of the class. And this is one way that we used to do enumerations in Java, but in Java 7 there is a way that you can create custom enumerations and you don't have to follow this method. We haven't learned about enumerations yet, which is why I'm not using them. So I'm going to use public static final int for now. Let me do the same thing for suits. So I made my new suits class, and now I'm going to create the constants of suits. Public static final int clubs. And I'll do the same for the other 3 suits. And once again, through the magic of video editing, I relieved you from the pain of watching me type all this in. What I've done is I've created 4 different suits. Now you might be wondering at this point, how do you use these ranks and suits? And let me just jump over to Playing Cards Run and give you an example. Because they're static, I don't need to declare them. I don't need to say suits s is new suits. Don't need to do that. I can do something like this. Int suit is suits dot clubs. Now you notice it's not, the IntelliSense is not working, and this says cannot find symbol. Again, I have to use my Control-Shift-I to import playing cards.suits. So I need to import the suits class from the playing cards package because I am currently in the playing cards run package. And you can see now I get suits clubs. I can also say suits dot, and it comes out, and clubs, diamonds, hearts, spades. Now when you look over this, you see it says JavaDoc not found. Either JavaDoc documentation for this item does not exist, or you've not added a specified JavaDoc in the Platform Manager or Library Manager. When we create our card class, we're going to build out some JavaDocs. And the advantage of building out the JavaDocs is as you use the objects, you can bring up documentation, that is, instructions on how to use the methods in the object. Let's go back and let's make our final class card. Okay, we're ready to build our card class. Now, if you remember from the last lesson we did, one of the first things you need to do when creating a class, which variables make up the internals of your class. And the way I'm going to implement my class is with a private int suit and a private int rank, because every card has a suit and a rank, like a 3 of clubs or an ace of diamonds. So as you saw before, clubs was a 0, etc., and deuce was a 0. So that's the implementation of my card. It's just simply going to hold a suit and a rank. So the next thing you need when you create a class is you need a constructor. So let's make our first constructor, public card. If you give it a rank and a suit, it should set this suit to suit and this rank to rank. And if you recall, the this keyword refers to the class that you're currently inside of, so card. When I say this dot suit, it's referring to this variable up here inside of card. The suit over here refers to the parameter that's passed into the constructor. Okay, let's go back and revisit that concept of JavaDoc. So now that I've created this constructor, maybe I want to document it. This is usually a good idea for all of your methods. Let's do it. And if I start my comma with 2 asterisks instead of 1 and press enter, it will automatically generate the stub for a JavaDoc. And the stub for a JavaDoc is always the same. On this line, I describe what this method does. So, creates a new card. Creates a new card. The first parameter is rank, the integer representation of the rank, ranks dot 3 or 2, for example. This is the int representation of the suit. So now that I've got some JavaDocs here, let's see what happens when we go to use our card class. So let me go back to Playing Cards Run here, and let's do this. All right, now I'm back here in my Playing Cards Run file, and I want to use the card class and see what the JavaDocs are. Before I can do that, though, I'm going to need to import card. Now, if I want to import suits and card, I could say import playing card suits, import playing card cards, like that. But instead of importing these two separately, because they come from the same package, I can say import playing cards dot star, and that'll import all of the classes inside the playing cards package. This is a very handy statement to use when you want to import more than one class from inside the same package. So now I can say card C is new card, and now I can invoke the code completion by pressing Control Space, and this will kick off Java documentation that I wrote in the class from within inside NetBeans. So you can see it says I need a rank and a suit, and they're integers. So I can say ranks dot 8 suits dot diamonds, and now I just made the 8 of diamonds. I could also say this, new card for 2, but I don't really know what that means because I don't know that 2 is diamonds and 4 is some digit, maybe the 6 of diamonds. So it's much easier to use the other classes. So I can say suit ranks dot 6 suits dot spades. Like I said, this is just one way to implement playing cards. There's a couple ways you could do it. This is just the way I chose to do it for now. Okay, let's go back and continue on building out our card class. All right, we have one constructor. Let's make another simpler constructor. Well, simpler to call, but more difficult to implement internally. How about if I said public card, and I only pass in one int, and I pass in int card number. You might say, well, what is a card number? Well, I'm going to get to that. Let's generate some JavaDocs. Creates a new card with a card number, integer representation of a card. 0 equals 2 of clubs, 13 2 of diamonds. This rank gets assigned the remainder of whatever card number you give me when you divide it by 13. And the suit is going to be the card number divided by 13, and that remainder of 4. So you have to think about this for a second, but let's go back to this example where 13 is the 2 of diamonds, right? So if I bring a 13 in here, the remainder of 13, when you divide it by 13, is 0. That represents 2 as a rank. If you take 13 and divide it by 13, you get 1. 1 is a remainder of when it's divided by 4. So 1 is suit diamonds. So this allows us to assign a single digit to any given card, 0 through 51. Card 52 is once again the 2 of clubs. It's another way that we can implement cards, and this makes it very easy for us to seed a random number into card to pull out a random card. This way we don't have to generate a random suit and a random rank. We just generate a random number, and then it makes a card from that single number. So for example, on playing cards run, I could say card D is new card, and I could say 13. Now that I have an overloaded constructor, this is one way to construct it. This is another way to construct it. And this is the same as saying 2 of diamonds. Okay, I'm back here in my card Java, and through the magic of copy and paste, I have implemented a bunch of methods. This one gets the rank. This one gets the suit. This one will tell you if the card is the same suit as some other card. This one will tell you if the card is the same rank as some other card. What this says is, you pass in a card C, and I'll compare this card's rank to C's rank. And if they're the same, then I'm going to return true. So I also have one called same card, and this one is a little more difficult. It says if the card has the same rank and the card has the same suit, then therefore it's got to be the same card. So this is the AND operator. So this same rank and this same suit. Okay. One of the reasons why I implemented my card the way I did was so that it would make it very easy for me to convert the card into a string to print. Now you might say, how does it make it easy? And the best way to do this is by showing you an example of printing out the card, and then I'll go back and discuss this code here that I wrote to do it. So let me just go back to playing cards run. Remember, I made these 2 cards. Let's print them out. First of all, how does println, the println method, know how to print this card? C is of type card. It doesn't know how to print a card. So what we do is, if you write a method in your class called toString, which returns a string, and you override the default of that method, you can then send that into any type of print statement and have that print statement treat the output as if it were a string. So when I run this, I should get 8 of diamonds and 2 of diamonds. To make it more interesting, let me change this card to 26, which is now going to be the 2 of hearts. So I got 8 of diamonds, 2 of hearts. I could do this. I could say c.toString here, but that's redundant. The println method will always try to treat the class that you give it as a string. That's why you need to put this override method here on card Java. So what does this method do? So first of all, I have a string ranks, and I rank them all in order. And then I have string suits, and you say, well, what are these funny symbols? Well, these are the Unicode symbols that give me clubs, diamonds, hearts, and spades, respectively. Clubs, diamonds, hearts, and spades. So this is a string of 13 characters. This is a string of 4 characters. 1, 2, 3, 4. They're Unicode symbols because I can't possibly type in the symbol diamond or the symbol heart on the keyboard, so I need to know its Unicode equivalent. And then what I'm returning is, if you take the ranks and pick the character at rank, right? So rank is what? It's this dot rank. And suit is this dot suit. For example, in the 2 of clubs case, this dot rank is 0. So position 0 in the string is right there. And the character at that position in the suit is right there. If I'm looking for the ace of spades, right? The ace of spades is card rank 12, right there, and suit 3, 0, 1, 2, 3, ace of spades. And just to show you that it really does work, if I go back over here and I say ranks ace, suits spades, and I execute that, I should see the ace of spades, which I do. So now you know why I implemented my cards the way I did. I chose to implement them in this manner so that it would be very easy to convert them to a string. And the way they get converted to a string is when I create this constant string that says ranks. Each position, this is position 0, position 1, position 2, position 3, position 4, and those match up with 0, 1, 2, 3, 4. All right, once again, through a little copy-paste magic, I've finished out a sample program by which I can generate a random number and then get one card, the ace of hearts, and then get another card, which is some random card between 0 and 51. And then I kind of talk about what the characteristics of each card is, and I can then run this one to show you what it does. So I have an ace of hearts and a 2 of hearts. Same rank, false. Same suit, true. Same card, false. So I'm just calling these methods that I wrote. So in a way, I wrote a program that kind of tests my card class to make sure that I implemented it correctly. You can see that there's a little bit of a disadvantage to writing a program like this, is that you have to inspect the output to verify that indeed it did work the way you expected. And this is where we segue into our next topic. When you start to get smart about writing your code, you start to think about, how can I write code to prove that the other code that I wrote works the way I expect? And this is what we call unit testing. The goal of unit testing is to reduce the chances of semantic errors. That is, you know that the syntax is correct, but is the program logic that you wrote in your method correct? So we write this code that then verifies that the methods that we did implement indeed work. And this is not always perfect, but at least it gets you most of the way there. And the goal of unit testing is to give you some confidence that you've written your code somewhat correctly. Maybe not perfectly, but you at least know that it's written with a certain degree of confidence correctly. The way we do this in Java is with a library called JUnit. JUnit is a helper library that will perform the unit tests. Let's try out a demo. Okay, we're back in our code again. I'm in card Java. Now I'm going to create a unit test for card Java. So watch this. I'm going to right click on source packages, new, other, and I'm going to pick unit tests, unit test for existing class, class to test. I'm going to browse my project and find card Java. So what I want to do is I want to write tests for the methods in card Java. That's what I just said. The other classes, ranks and suits, really don't have any methods to test, so I don't need to run any tests on them. These are all the options that you can set. You can just leave them kind of the way they are. And when you're done, you will get a new class called card test Java in a new package that has a bunch of methods in it. You'll see it says test rank, test suit, test same suit, test same rank, class. These are all methods that are just designed to test out various methods we wrote in the Java class. So if I run these tests, if I just run the program, it doesn't run the tests. I have to do something different to run the tests. I have to hit Control F6 if I want to run my tests. When I do, you see that these current tests all fail. And so my goal would be to make these tests pass. And let me do that now. I'll write one of them to pass, and then we'll leave the rest as kind of an exercise. I'm going to start with test rank. So you can see it says card instance null. I need to define my card first. So the first thing I'm going to do is make a new card. Let's say ranks queen, suits hearts. So I just made the queen of hearts. So what I'm expecting when I test the rank of the queen of hearts is that the rank should be queen. Now you might say, well, isn't this kind of stupid? I mean, I just made a card that's the queen of hearts, and now I'm expecting it to be a queen. No duh. And then this says is when I get the rank, I'm going to assert that what I expect to get back is what I really got back. And again, to that you might say, no duh. But this is the point of unit testing. Unit testing is testing the obvious, because when things fail, you know you have an obvious problem. That is, if I make a card that says it's the queen of hearts, and then I ask, are you the queen? And it comes back and says, no, I'm a king, you know you got a problem. And you know you have a bug in your code that needs to be fixed. So while building these tests sometimes can look a little foolish, there is a lot of value in doing this, because again, you're merely verifying that what you did right works as it should, as it's expected to. So the very last thing you should do when you clean out these tests, you need to get rid of the fail in here. So it's always the same. You always set it up, then you run your test by calling the actual method, and then you assert that what you expect to get is indeed matching up with what you got. So let's run the tests again. Control F6, and you should see that this test passed. So one test passed, the other tests failed. So as I go through, I want to get all my tests to pass by writing code that does it. So this one says test suit. I'll skip that one. That's similar. Let's do same suit. So like if I create a new card, and I can pick any card I want. Let's create the ranks ace of suits clubs. So I've got an ace of clubs. And let's make another card. And this is going to be, because we want to see if they're the same suit, right? So ranks 4 suits clubs. Are these the same suit? 4 clubs and an ace of clubs? Yes. So I expect true when I compare these, right? And the result is instant same suit. And then I assert, are those equal? If you want to test this more robustly, if robustly is a word, I could say card instance 2 is new card ranks jack suits hearts, and then Boolean expected result false, expected result 2 is false. And then I should have result 2, and this would be instance 2 same suit. And then those should be one assertion, and then I can make another assertion here with result 2. So what I did was I said, all right, I have an ace of clubs and a 4 of clubs. I expect those to be the same suit. I have an ace of clubs and a jack of hearts. I expect those to not be the same suit. So I'm a little more rigorous in my testing. Let's Control F6 this. And test rank passed and test same suit failed. Let's see what I did wrong here. Let's see if my expected result 2 to result 2, right? I need to compare. I expect it to be false, and it is false. So see, you got to write your test correctly too. So test same suit pass, test rank pass. So you can see I can write my other tests and get those to pass, and that's a goal. And one of the nice things about doing this, again, is when you finish writing all your tests and all your tests pass, you can then rewrite your card class. You can change the code inside the methods of your card class, and then to make sure that you didn't break anything, you can simply rerun your tests. And if all your tests pass, you could say with confidence that you probably did it correctly. And that concludes Lesson 7 on Java programming, where we introduced how to build your own JavaDocs and how to do basic testing of your Java classes. Thank you very much for watching. And again, I welcome your questions, comments, and feedback on YouTube. Goodbye now, until next time.